we have this lady, and her name was Alice in Wonderland, you know, the book written in the 19th century. Okay, and she falls into this black hole. Okay, falls forever and ever and ever and ever. I guess she does reach a bottom, but this is more or less the bottomless pit that the mathematicians are talking about when you fall into a black hole. One of their so-called black holes, okay, says you fall into this thing forever. You never reach the bottom, okay? And fortunately for Alice, she doesn't get stretched out of existence, you know, or completely to a little thread. She falls in one piece, apparently, okay? So she was lucky. Okay, so lots of people fall into rabbit holes, and they end up, you know, talking to rabbits and, you know, thinking nonsense stuff. Here's one guy, his name the Mad Hatter, and with his rabbit talking to Alice. And these people end up like her, more or less like her, talking to these weird characters, and they believe that these characters are real. But actually, you know, you should change the name. He's not a Mad Hatter, he's a Mad Hater. Okay, he's a mad hater. Some of these people then hate you, and they hate you for, you know, challenging their beliefs, their ridiculous beliefs, and they don't like that too much. And I had two fellas come over, and they threw a little rotten tomatoes in my face. One of them says the following. He says, if you want to prove something, learn math. Yeah, I guess if you prove, you know, in math, they do proofs in math. We don't do that in physics. That's in religion of math, but when they prove things, okay? And they're really tautologies. They're not, proofs in math are just tautologies. Whatever's on the one side of the equal sign is equal to whatever's on the other side of the equal sign. That's kind of, you know, redundant. It's a tautology. You're just stuttering. That's all you're doing. And so most scientific theories are then proven with math. Now, theories are not proven, first of all, and they're not proven with math because theory is an explanation, and math cannot explain. Math can only describe. It has no power whatsoever to explain. When you see an equation, it's not an explanation, it's a description, a mathematical description. And another fellow comes over and he says the following. He says, it's clear you don't understand physics or the scientific method, okay? Slap in the face, okay? Science is not about technologies. That is the province of engineering and applied physics. And no, he's absolutely right. Science is not about technologies. But he shouldn't tell that to me, I know that. But he should tell that to all the mathematical physicists on planet Earth, because they're all investigating stuff related to technology, and they call it physics. You know, they're trying to develop these supercomputers or, all kinds of devices that they go out there and invent or try to invent. And what happens? They're trying to make money, seeing if they can patent something. And what they're doing really is developing gadgets. And they don't know how a field works or how gravity works, and they don't care about any of that. What they're doing is doing technology. And that's one issue. The other issue is that, you know, a lot of the Nobel Prizes in physics, quotation there, are given for inventions. And you can look that up and you'll find out that many of them, I'd say at least 50% of them, have been given for inventions, if not more. So they don't give physics prizes for science, for explanations, for physical interpretation. They give physics prizes for developing technology. So you're talking to the wrong fellow. You should be talking to all these other mathematicians about that, because they don't seem to understand it. But then he continues, he says, in physics, that requires math models. No, absolutely not. If you're going to explain, like he says there, you must explain. If you're going to explain, you can't use math. Math has no power to explain again. It can only describe. That's the problem with math. It's very limited in what it can do. And then he said, provide predictions. No, we don't do predictions either. Again, that's a mathematical thing. If you know you're traveling in a straight line, your car is traveling in a straight line, 50 miles per hour, constant speed, you know you're going to be, you can predict, right? Predict that you're going to be 50 miles away from your starting point after 1 hour. Okay, that's a prediction. But that has nothing to do with an explanation. You haven't explained anything. All you said, hey, I can predict that you're going to be over here. A prediction is nothing more than a description. That's why mathematics has said that that science is about mathematics, because they can predict, they can measure, but what they cannot do is explain. Okay, and that's why they convert science into descriptions. Okay, and that's what we have today, just descriptions. The explanation part, which is what all these people really do, is always irrational, especially for all the invisible, intangible phenomena, or phenomena mediated by invisible, intangible entities. Okay, they have no explanation for that whatsoever, because they don't do objects, they don't do things. What they do is equations. Okay, and he gives some examples there, black holes among them, and instead of pseudoscience, crackpot claims all those actual facts are false. No, we don't claim that they're false. We claim they're irrational. The explanation is irrational. We say there's some phenomenon out there, obviously, and has a different explanation than the one provided by mathematical physics. So we have to put it in the right context. Okay, and these people try to take it out, and they're raising scarecrows here, saying that we're saying that they're wrong or they're false. We don't use those words. There's nothing wrong or false in science. Okay, you either have a rational explanation or you have an irrational one. And if it's irrational, it doesn't belong to science. That's where all of mathematical physics belongs, especially with regard to invisible, intangible mediators. Okay, so where does all this stuff come from? Where do these people get all these ideas? Well, they get them from the monastery. And here you have a series of people out there who make money, on the internet and on television, etc., where they spread the good news of mathematical physics. And you'll probably recognize some of these folks. Here they are. Okay, let me show you. Here goes. You have Bill Nye and Jim Al-Khalili, two fellows who are out there proselytizing. Here's some more, Sabine Hossenfelder and Brian Cox. All these people talk about all the nonsense of mathematical physics, and what they're giving you is explanations. They're giving you physical interpretations, all of which are irrational. Not one of the things that comes out of their mouth are rational. Okay? And so these are the heroes of today, and these are the people these people listen to, and the ones who they follow and whom they believe in. Okay, and this is where the problem stems from. So just keep in mind this is where it all begins. Okay, these people are the ones that brainwash the masses, and this is who the people believe in, because they see them every day on television, or almost every day, I'd say, and they think these are scientists. They think these are physicists, and they're not. They're just a bunch of mathematicians with the most irrational explanations they can offer for phenomena such as gravity, magnetism, light, workings of the atom, galaxies, etc. All of them are irrational explanations. Not one survives today. Not one survives science. Okay, here we have one famous, or somewhat famous. He's a lesser individual, but he's quite known out there. And he tells us that he's got a group of scientists who help him do his YouTube videos. And this is what he says. He says, I have physicists on my team who help with the research as well as make sure the information I present is accurate. When we produce videos outside my or my team's expertise, we consult appropriate experts to make sure our information is as accurate as possible. Good. No scientific theory can ever be proven. It can only be falsified. Well, we agree with the proven part. How about this notion that it can be falsified? Well, I don't know about that. So he says, so anytime someone asks where's the proof, I know I'm dealing with a non-scientist. What good old Arvin failed to realize is that falsification is proof. Okay, here it is. We kind of pointed out to them, when you say that you falsified something, all you're saying is that you convinced someone that something is false. In other words, you've proven to him. You made him believe. You made him change his mind and instead of thinking that it's truth, it's false. So falsification is a proof. And this is one of the people out there making money, trying to sell, the nonsense of mathematical physics. So, he already starts out on the wrong foot. That's what he has in his website. And you wonder about these people, because these are the people who are going to give their presentations, and people are going to listen and follow and say, oh, this guy's an intelligent guy. He knows what he's saying. No, he doesn't. If he talks about falsification and doesn't know that that's proof, same thing as proof, it's a synonym of proof, I don't know what to tell you. It means what did this guy learn in his life? Okay? Or while he was at the monastery, the mathematical monastery. And here we have another fellow, and a lot of you know him. His name is Sean Carroll, and he's going to tell us something, again, about fields in this case. And he's saying that particles are actually fields. Okay, here it goes.
Think about a magnet. A magnet is something you can attach to a piece of metal, right? It'll stick to it, a refrigerator or so forth. You can stick lots of things to lots of other things. You can stick pieces of tape or gum or whatever. But when you stick a piece of tape to the refrigerator, the tape has to touch the refrigerator in order to stick. The gum has to touch the refrigerator in order to stick. A little insect or gecko walking up the wall needs to touch the thing in order to stick to it. A magnet, if you hold it close to a piece of metal, you can feel it pulling before it touches. The magnet reaches across empty space and exerts a force, and the refrigerator exerts a force back, according to Sir Isaac Newton, that pulls the two things together. They don't need to touch each other. How is that possible? How does the magnet know that there is a refrigerator nearby that it should be attracted to? Sir Isaac Newton was very puzzled by this phenomenon, which is known as action at a distance. Newton was interested in gravity, not magnetism, but it's the same thing. The Earth exerts a force on the moon, or satellites orbiting the Earth. They're not touching each other. The Earth seems to push out across empty space to exert this force on things in its vicinity. Newton said that you can understand gravity throughout the universe in terms of an inverse square law. The force of gravity becomes weaker and weaker as you move away, as the distance between the two objects squared. But he was very worried. In fact, he said that this phenomenon of action at a distance made no sense.
Okay, so what we have here is all these people talking about action at a distance, and they're saying all these fields are actually particles, and particles are fields, and so what are we talking about? Are we talking about something that's concentrated at a point, meaning a particle, or are we talking about fields that extend forever, and which they say vibrate locally, and that's going to be called a particle? That's kind of like cheating. That's what it is. They're saying we're going to have the best of both worlds. We're going to have a localized thing as well as something that's extending all the way to the edge of the universe. And that is, you can't have both, but that's what they say that a field is. Oh. I think I went out of focus there. Okay, I think I'm back. Okay, let me know if you see me still there. Okay, so what does this Arvin guy have to say about that? Well, this is what he says, that fields are teeming with virtual particles that pop in from nowhere and then go back to being part of the field. And so, they cheat. They say that at the same time that the local vibration of the field is a particle, at the same time they say that these things pop in and out of the field, out of space, I guess, because space is a field, or covered with fields, or completely filled with fields. So these people, all they do with their physical interpretations are cheating. And so this other fellow who said, that you're supposed to explain, well, yeah, when you introduce magic, you can explain anything. These people are introducing ghosts and goblins. These people who listen to them, they think that the so-called scientists, the so-called physicists, that they're giving them a scientific presentation when what they're doing is not even fantasy, it's just totally irrationality. Can't even be imagined what these people are saying. Here's another fellow, and he talks about strings and gives you again the subject matter that these people talk about to the public. And some people believe them because they're just believing them on the basis of authority. They're saying, oh, he knows so much, he knows all that math. Yeah, but the explanation he's giving them is a bunch of bunk. And here you see Brian Greene. Listen to him. He's going to talk to us about strings. He's going to tell us what a string is made out of.
What is the orange made of? Molecules. And if I make them big enough deep inside, I begin to see atoms. We have electrons, mostly empty space in the atom, but deep inside, we see the nucleus. That the nucleus is itself made of particles, neutrons. I magnify it, I find little tiny quarks inside. And I magnify it, string theory says I'll find a little filament of energy, a little string-like filament. So a quark is nothing but a string vibrating in one pattern. An electron is nothing but a string vibrating in a different pattern. A neutrino, nothing but a string vibrating in a different pattern still. So if I take all of this back together, I have my ordinary orange. Deep inside the orange or any other piece of matter is nothing but a dancing, vibrating cosmic symphony of strings.
Now, isn't that a magic show? Was that all about magic? Everything is made out of strings. In fact, what's so weird here, you have the atom is a string, okay? And the proton is a string, a neutron is a string, the quarks and gluons that make them up also are strings. So they're all strings, but so you have all these nested strings, okay, vibrations of strings. And so what sense does that make? What does that bias? What does that tell us about the universe? Okay, and then of course, the strings, as you can see, they're all closed loop. And so they're separated from other strings, meaning that you have a discrete particle here and a discrete particle there, okay? And the question is, does that make any sense that you have these vibrating strings and that's what an atom is? And assuming it were correct, if that's the case, so what? So what can you tell me about gravity? Why does a pen fall to the floor? Why does a magnet attract another? And they cannot answer those questions, and they're talking about things that they invent, that the particles are made of strings, closed loop strings. Okay, but here we have Leo Susskind, another fellow, and he's going to tell us what the string itself is made of. If everything is made out of strings, what are the strings made out of? I think a lot of people want to ask that question, and it's interesting to hear his answer. Okay, so here goes. Here goes.
Is there any either evidence or reason to believe that, in some sense, strings are the most fundamental things? Could strings be made of other things? In the march of reductionism, is there some sense in which strings are the most fundamental things in the world and there's nothing smaller than them, or they're not made of anything? And I gave an answer which was the ultimate hedge, or the ultimate waffle, and that was, we have learned that that's not a good question. The question of whether something is composite or fundamental should really be asked in the following way. You should ask, is it useful to think of it one way or the other, and whether it's useful or not may depend on the values of the parameters in the theory. So there's no invariant ultimate answer to the question, which is more fundamental. It's a question of which is useful. Fundamental means it can't decay, and composite means it can decay, it can break up, it can fall apart. Are strings fundamental? There is one set of parameters in the theory where strings are made up out of little things called d-branes. You change the parameters and you find that d-branes are made up out of the strings. So it's a question of useful. There are ranges of the parameters of the theory where it's useful to think of the strings as the most fundamental objects. You can shift the parameters and find ranges of parameters where the things that are called d-branes, which previously had been thought of as big fat composite objects, morph into tiny things, and the strings themselves blow up into big fat composites. This is a lesson that I think physics has been driving at for some time. the sort of continuous march of reductionism. Smaller things made of smaller things made of smaller things, and some ultimate sense of what the most fundamental thing is. That does not seem to be the way things are going. The way things are going is that things morph into each other when you change the parameters in the theory, and what was fundamental can become composite, what was composite can become fundamental. What the ultimate lesson to learn there, nobody knows.
So now you know, strings are made of D-branes, and D-branes are made of strings, on and on and on. And where it leads mathematical physics, nobody knows. So that's the state of science today, it's a state of physics. Okay, and finally we have another fellow here, another example to show that all these people talk nonsense. His name is Matt O'Dowd. He has Space-Time on PBS. And this is what he has to say. Listen to his version. Here it goes. The Higgs boson, by the way. Here it goes.
Now take the photon. It is definitely massless. It travels at the speed of light, and it experiences its entire existence in an instant. A photon only changes if it bumps into something else. But the photon and the electron are both just excitations in their own fields. So why does the electron have mass and the photon not? While the photon can cross the entire observable universe without bumping into a single thing, the electron is never not bumping into things. There's something in the substrate of space everywhere that impedes the electron. It's the Higgs field. The Higgs field is really weird. The Higgs field has a positive strength at all points in the universe. There's a little bit of Higgsiness everywhere. This makes the Higgs field an infinite source and sink of weak hypercharge. On its own, the electron would travel at light speed, but trapped in this Higgs field buzz, the electron feels mass. Honestly, this is a pretty wild story. An invisible and infinite ocean of some sort of charge that we've never heard of, all invented so that electrons can be left and right-handed at the same time. How do we know it's true? Well, something like this must be true, because all of the rest of quantum field theory hangs together too well. We conclude that QFT is essentially correct, but it's an incomplete theory without a mass-giving field. The Higgs field is the best, least silly option to do this, but how do we prove it? Enter the Higgs boson. Just like the other fields, the Higgs field can vibrate around its baseline value, which gives us the boson. This particle actually has nothing to do with giving anything mass. However, if we observe the particle, then it means that the field also exists. It seems very likely that the LHC did produce the Higgs boson, which in turn would mean that the field exists. Could the Higgs field also explain things like dark energy, inflation? There are reasons to think it might.
Yeah, all theorists believe that they can explain everything with the Higgs boson. And yeah, this fellow is a caricature of a scientist, of a physicist. He has no idea what physics is about. And what they do is they go around in circles. They'll never give you a rational physical interpretation. And later on, they dismiss it as philosophy. Why are they giving you a physical interpretation if they say, first of all, that it's not part of their line of work, their job description? That's on the one hand. And then the other, if they only do math, why do they even take the trouble, right? And then they give you an irrational one anyway, so why did they even take the trouble? That's a question you should be asking. And that's not the worst part of it. All these so-called scientists, that are on the internet and on television, they had to branch out into other disciplines, and they become experts in other topics. They're not, or maybe their bucket of physics is completely full. They've already talked about everything they could, and so they have to branch out into other, line items. And so they start talking about other stuff where they give their opinions as experts. Again, they're always experts, right? And let me show you some examples here. Here's a lady known by Sabine Hossenfelder, and she talks about nuclear waste and about climate change. Okay, is she an expert on that? Why is she being called to do that? I thought she was a physicist. Okay, she's giving you her opinion on these subjects. She also talks about electric cars and whether women athletes, should be competing against, the people who change their sex, against men who change their sex to women. Here you have another fellow. His name is Roger Penrose, and what does he talk about? He talks about consciousness and whether a creator exists. Okay, he's supposed to be a physicist, right? This is what they're talking about. They're going into stuff that you would think involves philosophy, psychiatrists, or psychologists. And these people are giving you their expert opinion on that. Why are they being called to give expert opinions on subjects that are not part of their discipline? And here's another one. His name is Nick Lucid. And he talks about autism, okay, and other subjects like, in this case, whether you should work or whether you should be working so hard, for a living, I guess. Take it easy, he's saying, right? They're giving you their opinions, and a lot of people might believe them because they say, oh, these are experts. They're on TV, they're my heroes, whatever. Here's another one, Michio Kaku. He talks about brain size comparison, okay? Talking about the complexities of the brain. Is he going to become a surgeon, a brain surgeon? Why is he talking about subject matter why is he being called to talk about these subjects? Or he talks about Hawking's opinion on God, Again, religion, are they experts in religion or what? Why are they being called upon to talk about these subjects? Here's Bill Nye. He talks again also about religion, creationism, and whether we should teach that to children, like the monkey trial, a long time ago. And he talks about nuclear power, Monsanto and other stuff, changing your mind. Why are these people being called to talk about these subjects? Shouldn't they be called to talk about physics? Is it that they have their plate already saturated, all the physics subjects saturated, and now they need to talk about something else as if they were experts because they're being brought in as experts? Here's another fellow. His name is Neil Tyson, and he Neil deGrasse Tyson, right? And he talks about gender, and someone accused him also of putting his hands where they don't belong. And he went to Barbie Land in Florida. Great. This is subject matter of physics. Why is he being called to talk about these petty subjects? Is he some kind of expert? Why are they calling him for all this stuff? Or are they bringing him on the basis of, again, authority? Like he's a known figure, so to bring in the hits, they bring him in to talk about anything that has nothing to do with physics. Okay, here's another fellow. His name is Brian Greene. What does he talk about? He talks about consciousness and psychedelic. Whether you should be popping pills in your mouth, I guess, or shooting up. Great subjects. I don't know if he's an expert on that. Has he shot up, or is that why he's bringing these subjects up? And here's another Brian. His name is Brian Cox, and get him up here. And he's talking about aliens and what it means to be human. And how would he know? How would he know what it means to be human? I don't know. These people come in there with their opinions. Are they worth anything, their opinions, or are they worth as much as the next guy over? Why do they bring these so-called physicists? Are they supposed to give you a better opinion than the next guy down? Okay, so I guess they're making money by branching off into these other subjects, right? Okay, so what do you see in the publications today? What are people publishing out there? And here you see they publish these images, right? This is supposed to be a black hole. This is what they feed the public, and comes from all these people. Also, they will put it on their websites and on their YouTube videos. And that's what they show you. That's You say, okay, that looks fantastic, right? But it turns out that's just a drawing, an image that someone made, or a computer-made image. This is what they actually see in the night sky. And from this, they conclude, they infer that, that you have these black holes. I mean, can you tell by looking at this that you're staring at a black hole? And what they do, they look at what's happening to the mass or the, I guess, the suns and the gases in the region. They say, oh, it's moving so fast, there must be so much mass that's causing it. And what else could it be if not a black hole, which is all mass and no matter? Okay, that's more or less the situation. That's how they prove all these things, and they feed this to the public. Here you have it in the other world, in the quantum world, and this is what they show you. And you see these so-called traces down at the lower left and the upper right. And you see the atom there, this is the typical atom, a bunch of little balls in the center. And I guess they're orbited by all these other particles that are supposed to be electrons. Is this a picture that they took somewhere in a lab, somewhere with high-powered microscopes? No, this is what they see with their high-powered microscopes. And there you do not see any little electron beads flying around. What you see is a ball, or something that looks like a ball in 2D, the 2D version of a ball. Okay, you can see there on the upper right, sticking up from the metal there, IBM it says, by the way. And you can see that the atoms have kind of like structure. You don't see a little bead going around a proton. Okay, so one thing is what they illustrate. They constantly illustrate a lot of stuff, and what they actually see is stuff like this. So you wonder how much are you being cheated by all these false representations of so-called physicists, and the images that they show you, they're not real. 99% of the stuff that you see out there today is not real. It's because they can't see it. It's not real simply because they can't see it. They have to make a drawing of what they think it is. And the drawing shows, if it shows a bead with a electron bead moving around it, around the proton center, then you have to ask the valid question. Why does the bead fly away? What keeps it tied to the proton, to the nucleus? And these are questions you'll never have an answer to. Okay, I mean, one is negative, one is positive. The negative should fall and be attracted by the positive and stick to the center. And opposite of that, why doesn't it just fly away? And they can't tell you that. But that's what they illustrate, but that's not what they see. And they talk about observation. Okay, so here we have good old Alice falling down a black hole, I think. Rabbit hole, I thought it was originally, but today I guess she's falling down a black hole. And she goes down forever. She'll fall all the way until she hits nothing. She will just fall forever. And you can picture her again stretched completely if she falls into a black hole, so that she's like a little rubber band being stretched, okay, from the event horizon to the singularity. Okay, that's one way of looking at her. But yeah, this is how these mathematicians have been falling for the last 400 years. They've been falling and falling into black holes because they actually painted themselves into a corner. They think they can figure out how this universe works by looking at the math, by looking at equations, meaning descriptions. And what people are asking or expecting from them are explanations. Since they cannot give you an explanation, what they give you is the next best thing for them, which is irrationalities. They say, look, we think this is the answer to your question. And the answer is totally irrational. And when you put them against the wall, they say, well, by the way, we don't care about that because what we do is math. So why did you attempt to tell me that you're an expert in physics, in physical interpretations, if all your explanations are irrational? That's the question that you have to pose to them. So we're back to our tea party. Okay, and here we have these people who have fallen into a black hole, and they're, with Alice there, I guess, Sabine, and they're all, just talking nonsense for the last 100 years. And these are the disciplines. This is where we ended up, with all these people giving you irrational explanations for everything that's been up there. The only guy I would really like to see there is good old Einstein. You know, he was one of the guys who started all this mess about 100 years ago, a little over 100 years ago. And I wish he would have fallen into the black hole, the Alice's rabbit hole, Wonderland world, and maybe got to see the Queen, you know. And according to the tale, it says that the Queen sentenced the Mad Hatter, right? Sentenced him to death because she accused him. She says, "You killed the time." And Einstein, I think, did kill the time for sure, okay? And, you know, maybe the Queen should have put him, you know, in a stockade like that and then chopped off his head if she was really going to go through with her idea that, you know, that he deserved the death penalty, okay? Anyways, that's the story for you today. And all I can tell you is whatever comes out of mathematical physics, you can't even take with a grain of salt. It's just worthless garbage. It's nonsense poppycock. We don't have any more science out there. Everything you read in the scientific literature, so-called scientific literature, none of it is science. They're all doing black holes, they're doing dark matter, they're doing dark energy, wormholes, parallel universes, Big Bang. That's on the cosmological side. On the Lilliputian side, you have the atoms and what comes below that, which are all these phenomena slash particles, things that they can't see, which they imagine to be particles, and they invent new words for them every day. They mediate all transactions with energy, with force, with waves, with time. You know, these are the mediators, the physical mediators, and they're all their physical interpretations. And so nothing that comes out of science today is rational anymore. And it's very, you know, discouraging. What can you say? This the world we live in. This is the world we ended up with after doing math for 400 years.